Is this a joke?
What?
You're kidding, right?
Quick, help me solve these. What do I need to do?
Nothing. It's
Plus
just easy.
4
Plus 4, sweet. I'm gonna write this in
divided
red.
by 2.
Hold up, I'm gonna write this in red so we know
X
it's the
equals
answer.
3.
And by red I mean green. Can everyone see this right now?
Yeah, that's fine.
Okay, good. So 2x equals 6 divided by 2 divided by 2,
X equals
so
3.
x equals 3. Sweet. Next one.
27 divided by 3 is
Perfect.
9. Square root that, and that's 3.
What kind of 3?
X equals 3. But these
Plus or minus 3.
Plus or minus 3.
plus.
Because 3 squared is 9 and negative 3 squared is also 9. Okay, next one. Uh-oh.
This would be factoring.
It would be. So factors of 6, I'll just cheat us through this. We've got 6 and 1. We've got 2 and 3. Well, I need a positive 1, so I want plus 3 minus 2. So this will be x plus 3, x minus 2.
So it's x equals negative 3 and x equals 2.
Perfect. Oh, that was horrible. That was like a 3 and a 2. What's the other way I could solve this one? Uses a fancy formula that people probably sang to you a bunch of times.
The quadratic formula?
Yeah, so x equals negative b plus or minus square root b squared minus 4ac all over, yeah, that thing, right? Where b is 1, c is 6, negative 6, and a is 1. I'm going to actually run through this right now to remind us. So this is negative 1 plus or minus, this is 1 squared minus 4 times 1 doesn't matter, so negative 6 all over 2. So x is equal to, this is negative 1 plus or minus, this is going to be square root of 1 plus 24. Oh man, this is crazy. It's insane. Okay, and then this is square root of 25, which is just 5. And then we're going to get the same exact thing. We're going to get a negative 3 and a positive 2. So I'd have x equals negative 1 plus 5 over 2, or x equals negative 1 minus 5 over 2. Good refresher? This is familiar? Who's moaning? Is that a boredom moan?
How are you unable to tell who's like?
Alright, last one.
Anytime someone says something, I can hear them.
What you're saying, Liam? You can or can't hear?
Or Mr. Bennett.
Alright, how would I solve x squared minus 4?
Add 4 square root.
You could do add 4 square root. You could also recognize this as differences of squares, right? This would be x squared equals 4 square root. So x equals plus or minus 4. Or you could say, well, this is x plus 2 times x minus 2.
Plus or minus 2.
Thank you. I noticed that as I was writing the factors. See, it's good to do things 2 different ways sometimes, because then you realize you messed up. Like I just did. And then we'd get the same thing. So x equals negative 2 or x equals 2. Alright, how many people are like, why are we doing this?
I don't think anybody.
Nobody. That's good. How many people were like, oh, I know a lot of people when I first said it were like, oh, these, really? So, yeah, like, this is simple to do, right? This is just algebra. So, the next part of 6.6 is literally what we just did, except we then use, I'm going to switch back to sine and cos, sorry, blank. So I've got 4 sine of theta minus 2 equals -4. There's pretty much no difference from what I just did to what we should be doing here. The one thing that's different is that instead of having a variable, we now have a trig function, which we can honestly pretend is a variable to start.
Oh, okay.
That's it. That's all the rest of 6.6 is going to be, is taking your trig function and treating it like a variable and then plugging it back in later. So how would I walk through this one?
You would add 2.
Plus
So you
2.
said. Yeah.
So I'm going to get 4. I'm actually literally going to write x right now and say this is equal to -2.
Divide that, that would be -1/2.
So I got x is -1/2. And now I'm just going to put sine back in. So sine of theta is equal to -1/2. So now all we need to do is, our first step was use algebra to get us into a simplified form. The second step is then just use your unit circle or identities to help you out. So for this one, all we're doing is looking at sine of theta is equal to a -1/2. We're going to be in quadrants 3 or 4. This will give us 7 pi over 6 or 11 pi over 6. I'm going to quickly, oh wait, I have a cool tool that can save me time for drawing circles. That's the selection, it's not brush. Oops. So this is pi, which would be 6 pi over 6, so 7 pi over 6 would just be a little bit further. And then the y value here is just 1/2. We then did our reference line across. We know this is 2 pi, which is 12 pi over 6. So this would be just a little bit short, so this would be 11 pi over 6. So all we're doing for the rest of 6.6 is solving essentially algebraic equations and then using the trig function. I forgot to define this as 0 is less than or equal to theta is less than 2 pi. This does matter. We're going to see why this matters in a different example. Okay. Let's move on down. So we're going to solve 2 cosine squared theta plus cosine of theta minus 1 is equal to 0 for 0 is less than or equal to theta is less than 2 pi. The first step again is to just treat your cosine theta as a variable. So this is x squared and this is x. So really I have 2x squared plus x minus 1 equals 0. Okay, my next step, I personally prefer using the quadratic formula just because it's kind of ingrained in my brain. You could do this doing factoring. How many people learned the slip and slide method for factoring when they were in algebra? Does that term ring a bell for anyone or no?
No, not for me.
You mean like the rainbow, where you move the 2 to the -1 and like multiply it?
Yeah,
Yeah.
Yeah.
The rainbow method, okay. Yeah, so that's the other way you could do the factoring. So really we'd have x squared plus x minus 2. This would give you a plus 2 minus 1. So we'd have x, this would need to be positive 2, x minus 1, and then divide by your halves. So we'd have x is plus 1, and then this would be 2x minus 1. From there, we would just solve each piece. We now have two factors. If one of them equals 0, the whole thing is 0. So either we have x equals negative 1. In this one, we'd have 2x is equal to a half. So equal to 1. So x is equal to a half. For this one, factoring might be quicker. If you did things with the quadratic formula, you'd get the same results. We now have two things we need to look at, so we're going to go back and look at x as cosine. So I said x equals cosine of theta. So now I have cosine of theta is equal to negative 1, and I have cosine of theta is equal to a half. So I just have to find when what angles, remember cosine gives me my x-coordinate. So what angles give me negative 1 for my x-coordinate, and what angles give me a half for my x-coordinate. If you have your unit circle in front of you, want to shout those out for me, that'd be great.
Would the first one be pi?
Pi, yep.
And the second one would be, I think, pi over 3.
Pi over 3, and then there's one more.
And then there's 5 pi over 3.
5 pi over 3, perfect. So looking here at pi, my x is negative 1. Pi over 3 is before pi over 2. X is only going a half. And then we do the reference, which brings us to 5 pi over 3. Did anybody watch the link that I posted with the hand method?
No, I didn't.
So like if you're still really confused by the unit circle, in the post I made a link to a teacher who teaches a kinesthetic activity, which means like using your hands to help understand the unit circle. So if you're still like, I really struggle with the unit circle and you want to do something kind of manipulative, I think it's pretty helpful. So in this case, we have 3 possible solutions. We get 1 solution from cosine of theta for negative 1, and 2 from cosine of theta is equal to a half. Any questions so far? I'm going to take silence as a no. Alright. I need to do one that's not. Wait, do I just give us I think I give us. Yeah. So in yesterday's topic, we saw examples where you might have to add the period. Going forward, it seems like we only have problems that give you the period. So you're always going to be given that theta should be between 2. Okay. This is number 3. For here, we've got tan of theta squared plus tangent of theta equals 6. I'm going to quickly make a new circle. What is tangent as a fraction?
I think x over y.
Close.
Or is it y over x?
It's
Y over x.
Yep.
Yeah.
Does anyone recall what the period for tangent is? If not, we can derive it.
I think it's pi over 2.
Alright, so I've got pi over 2, this is 0, this is pi, this is 3 pi over 2. Where can tangent not be defined?
I don't know.
So there's currently 2 angles out of the 4 I have here where tangent won't be defined.
Pi over 2 through pi, and then 3 pi over 2 to 0.
So I'm just going to stick with the actual first things you said. So at pi over 2, why did you say pi over 2?
I was just doing the alternate state chemistry thing. I don't know if that's the right thing.
It's not quite, but I like that you said pi over 2. Why can't tangent be defined at pi over 2? What is y at pi over 2? In the unit circle.
1.
1. What is x at pi over 2?
1. Oh wait, 0, 0, 0.
0. So we get a divide by 0 error, which means that we can't have tangent at pi over 2.
Right.
What's x at 3 pi over 2?
0.
Also 0. So, tangent is only actually defined to have a period of pi. Because once I hit pi over 2, I'm going to have an asymptote on my graph, which means tangent doesn't exist. And at 3 pi over 2, I'm also going to have an asymptote, so 3 pi over 2 wouldn't work either. So instead of being from 0 to 2 pi, tangent is only going to be from 0 to pi. And we're going to just assume x does not equal 0. Okay, so now that I have the period, I'm going to be restricting the number of answers I'll get. I'm only be looking for answers in quadrants. In this case, this is quadrant 1 to quadrant 2. I'm going to go do this in blue. So then I'm just going to do the same thing I was doing before. I'll treat this as x squared. I'll treat this as x. So now I have x squared plus x is equal to 6. And how would I go about solving this one?
You'd subtract 6 first.
Perfect. So I have x squared plus 6 minus x is equal to 0. And then I could do either quadratic formula or I could do factoring. I believe we get nice factors for this one. Yeah, we can get nice factors for this. Oh, we actually had this one earlier. We did this earlier.
3, negative 2.
Yep. We did this exact setup in one of the first examples. This is all equal to 0. So I have x is negative 3, where x is equal to 2. Negative 2. No. Oh, you know I did wrong. That's fine. It's not going to be a big deal. I technically wrote this wrong. It was supposed to be a little bit different, but it's not an issue. I just changed my signs of my factors. I originally had negative tan of theta in my notes, but that's okay. Alright, so now we can go back and we can plug in tangent of theta. So I have tan of theta is equal to -3. And I have tangent of theta is equal to 2. I could waste my life trying to find what theta is equal to, or I could be smart. I'm gonna pause my. We can just use the inverse functions that we've learned. So in this case, I could just take tan inverse of both sides. I'd have theta is equal to tan inverse of -3. And I'd have theta is equal to tan inverse of 2. I'm then going to, if you have a calculator on you right now, you could do these in your calculator. I'm going to put these in radian form. Let me make sure I'm in radian form. I'm good. So I have tan inverse of -3 is going to give me -1.249. And tan inverse of 2 is going to give me 1.107.
What's up, Sash?
Okay. So I went through and I used my calculator just to get the two values. I'm going to draw this one in. I currently have a negative angle, which isn't great. I would have to add a value to it to be able to determine its reference angle. In this case, I'm just going to add, just need to add a pi. So I'm just going to add 3.14 to be able to get it as a positive angle. 1.249 plus 3.14. It's going to be 1.89. Okay, so from here, I now have my two angles as 1.891 radians and 1.107 radians. The only catch though is, since this theta was technically a negative, this is great that we have a reference angle, but since it was a negative angle, that's not between 0 and pi. That's why we have to find what the equivalent form would be in quadrants 1 and 2. So now this is between 0 and 1, and then 0 and pi. This is between 0 and 3.14. And then for our second theta, this is also between 0 and 3.14. So this again comes to the fact that tangent is a periodic function. So this angle, which was at -1.249, will repeat. So we'll have -3 again at angle 1.891. Okay, we are at how much time? We're at half an hour. I'm going to just give us one quick more one. Since we've only done one with inverses, but this one I will give us a I'm just trying to figure out which ones to do and not do. I want one that has inverses. So we're going to do this first one. This is actually going to be the last problem for today. I'll leave 3 as practice if you want to do. It's not required at all. It'd essentially be as if I was just giving you practice problems to do in class. So we have, for the last one that we'll go through together, number 4, we have 2 cosine squared of theta plus 5 cosine theta minus 6 is equal to 0. Again, this is going to be from 0 to 2 pi. This one's actually going to show why we have to use the quadratic formula. If I were to try to do the factoring, I would have 2 times negative 6 is a negative 12. There are no factors for, and this is 2 and 6. There are no factors for 12 that would get us to 5. So we're going to have to use the quadratic formula. So this is going to be x squared. This is going to be x. So I really have 2x squared plus 5 minus 6 is equal to 0. So I have my a as 2, b as 5, c as negative 6. So I get x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So I'm going to have negative 5 plus or minus the square root. This is going to be b squared is 25 minus 4 times 2 is negative 8. Negative 8 times negative 6 is plus 48. All over 2 times 2 is 4. This is going to give me 73. So negative 5 plus or minus square root 73 all over 4. And then from here you could use your calculator to get the values. I'm going to go ahead and skip that step. This would just be plugging it in exactly as you see it. I'm doing one as negative 5 plus square root of 73 divided by 4, and the second as negative 5 minus square root of 73 divided by 4. You're going to get x is equal to negative 3.386, or x is equal to 0.886. From here, it's just reapplying what x is equal to. So cosine of theta is equal to negative 3.386, or cosine of theta is equal to 0.886. What is the range of cosine? In other words, what's the maximum value? I think someone was saying something.
I think it was 2 pi.
So that would be an angle for range. We know cosine takes in an angle and it gives out a coordinate. So if we look at a circle again, what's the maximum coordinate value for x on the unit circle?
1.
1. What's the minimum value?
0.
Here's 0. So I could go further to pi. What would I be at pi? Not 0.
The x value?
The
x value?
Yep, what would be the x value at pi?
-1.
-1. So my range to recall for sine and cosine, sine and cosine is -1 to 1. So can I have cosine of theta equal to -3.386? Is -3.386 in my range?
No.
No. So this answer here is not actually a real solution. So this does not matter. So the only thing I need to do is now solve for cosine inverse of 0.886. So I'm going to do theta is equal to cosine inverse of 0.886. This is going to give me theta is equal to 0.153 pi. Not 0.153 pi. Hold on. Just 0.153? Or did I already went through and subtracted. That's right. In my notes I already put this in terms of pi for us. If you wrote this out originally, you would get, so in your calculator you will get 0.482. I then went and turned it into a radian with pi by doing the times pi over 180, which I'm going to double check. Sorry, no, I just divided by pi. I just did divided by pi. Duh. Because I can do this as times pi over pi, which is just 1, right? From here, we know technically cosine can happen twice. So I have 0.153 pi, somewhere around there. We're going to take a guess. I know cosine can be positive in quadrants 1 and 4. So now it's just finding the same angle for quadrant 4 as a reference. To find this, just as a quick refresher, does anyone remember how we would find the angle? If not, that's okay. We've been a while from it for a while. So when dealing with cosine, I know, so this is my theta. Realistically, I'm now looking at 2 pi, and I'm subtracting theta from it. So to find my second answer, I'm going to say or theta is equal to 2 pi minus 0.153 pi, which is equal to 1.847 pi. That's it for the notes today. It's really just understanding algebraic manipulations and being able to solve algebraic equations. I'm going to write some examples down. You don't have to copy them. They're going to be posted within the notes, so you can just check the class notebook for that after this.